with greatest common divisors, we sort of saw the largest thing that can be shared on the inside of a group of numbers, and with least common multiples, we're seeing what the smallest thing is that we can sort of capture them all in, as the least common multiple is essentially, for a group of natural numbers, the smallest value that contains all of them as a divisor. So thinking back to how we started, we could say that the least common multiple of 2 and 3 is 6, where if all we have in a case like that is prime numbers, the least common multiple is unfortunately going to be just the product of them all, because we don't have that many options to work with anyway. But in general, if we have a bit more that we can talk about, and we want to get the least common multiple, we can follow a pretty repetitive process where we write the prime factorization of each number we're considering, select every prime factor that occurs, raised to the greatest power to which it occurs in these factorizations, and then form the product from there, where the LCM, least common multiple, is going to be that product. So it's actually kind of the opposite of a process for the greatest common divisor, and when we're working on the worksheet later on with this stuff, you'll see that there's actually a connection between those two in the special case of looking at two values. But for now, we're going to take a couple of examples. So for our first example, we want to find the LCM, least common multiple, of 36 and 48. So I'm not going to go through the steps of showing the factorizations of 36 and 48, the factor trees there, but you can pull those apart essentially into a 4, 9, and a 16 and 3. So what you would have is, if you factorize these, 36 is equal to 2 squared, or 4, times 3 squared, or 9, while 48 is going to be equal to 2 cubed, like I said. Oh, let's get ahead of myself there. 2 cubed, or 8, multiplied by, all right, not 2 cubed even. I did get really ahead of myself. I should have been 3 there. 2 to the 4th, because I need 16, or 3. Where from there, what we're going to want to do is recognize which appears the most in here, where we get the most 3s from up here and the most 2s from down there. This is a very convenient case to start with because all we have are 2s and 3s. There's not very much consideration that has to be done in terms of finding the largest amount of each power, but let's also think about this as being almost the opposite of what we did for the GCD, and that hints at that property I was talking about. But in this case, we've identified our grouping, so if you want to get the LCM, all we have to do then is just multiply them out. So 2 to the 4th times 3 squared, which here, 2 times 2 times 2 times 2, that would be that 16. 3 squared is 9, so 16 times 9 would give us a least common multiple of these two, which equals 144. And as a simple example, let's get one more here that's a bit of an application.